Hi everyone, so today I wanted to provide a bit more insight into the actual machine learning process itself. So we've got a problem in our minds, so that's that people abandon online forms and checkouts. We want to be able to predict when that's going to happen in the future based on customer behavior. So that's a problem that we're trying to solve, and we're trying to do that through the process of machine learning. So once you have that problem, there are kind of 4 steps that you can see along the top that you go through. One is selecting and collecting data that you think is going to be relevant to that problem. And at that stage, it's still pretty raw. So for us, that's just kind of an event log of what different people are doing in a form. So a click here, a key press there. What you then do is sort of pre-process that. So you put it in a sort of framework or way that you can look at and you can sample and you can take chunks out of. The next bit, which I'm going to focus on today, is kind of a little bit of where the magic of machine learning happens. So you transform that data before you start to apply machine learning models to it, which is the last step. So once you've done the first 3 steps, which is largely to do with data collection and interpretation, you then apply a machine learning model to it. I kind of want to focus on the transforming data step, because I think that's a lot of where the mystery and the complications come from in machine learning. So in order to get the most from whatever machine learning model you pick in the last step, the key is to present the data to that model in a way that's most effective. And data on the whole is presented to machine learning models as features. So those are attributes of your data that are meaningful to the problem. So again, I talked about our log of just what people are doing in online forms and checkouts. We could try and apply a model to that, but we think there's sort of some interpretation and ways to kind of package that data that would allow us to more effectively make predictions. And that process of turning that raw data into kind of attributes is the process of creating features. Why do you want good features? Well, the better the features you have are, it gives you more flexibility in terms of the models that you can choose. It means that you can run models faster. So for us, speed is really key. Bearing in mind that we're trying to make predictions in real time, it's key for us to have faster models. And most importantly, you get better results. So the better your features are, the higher the likelihood that you're going to get better results are. So let's talk about these 3. Feature engineering. So what that is effectively creating features from the raw data. Why do you want to do that? Because you want features that better represent the underlying problem that you're trying to fix. So although you could pump our raw data log into the machine learning model, we feel that doesn't really represent the problem that we're trying to solve, which is how are people behaving in forms and what kind of characteristics, what sort of pockets of behavior are indicative of abandonment. So feature engineering is taking that raw data and picking out features that are more relevant to the problem than just the raw data dump. Feature extraction is really interesting as well. Let's say, for example, you've taken your raw data and you've come up with, say, a dozen features. Feature extraction is taking that set of features and perhaps combining them or seeing the relationship between them to generate new features from your existing feature set. So you have 12, but you realize, oh, if I compare the ratio of this one to this one, that's also an interesting feature. So you're generating new features off the back of the ones that you've already created. Now, the final one, feature selection, is taking a large group of features and narrowing that down to a subset of those to the ones that are most relevant and get best results. So feature selection, I guess, is kind of the easiest step because you're taking the hard work that you have done and simply refining it and narrowing it down. But this by no means happens in a particular order, and it's not finished at any one point. You'll often go back to your data and say, great, we've got some features, let's extract some more, or let's cut out some, because we've seen when we cut this one out, we get better results. Once you've been through that process and you feel ready to move on to the next step, that's when you take your features and you apply different models to them. And in a different video in the future, I'll talk a bit more about how we actually going about modeling data and applying algorithms to it. So perhaps the best way to explain how all of this process works is to talk through an example. One that's often mentioned is to do with applying machine learning to image recognition. Let's say, for example, that you wanted to be able to recognize horses from non-horses in images. here is a beautiful horse that I've drawn. As you can tell, I'm a budding artist as well as a startup co-founder. So what you will want to do, so that's your problem, what you will want to do is select data. Those are probably going to be images, and then those images are uploaded into a computer. You then want to process them in a way that you can look at individual pixels, and then this step is where we transform that data. Now you could literally just cram those images into a machine learning model, pixel by pixel, but it would likely be slow, pretty inaccurate, and basically not be good at solving the problem that you're trying to fix. So, if we wanted to be smart about recognizing horses, maybe a first step might be is taking that raw data, but then within those pixels of those images, being able to spot curves, straight lines, trees, slightly more complicated now. If you were trying to recognize horses, you might want to recognize legs, or backs, or manes, or faces of horses. So that might be the process of feature engineering. What you also might be able to do is take combinations of those. So you might say, okay, we can recognize legs, we can also recognize length. So how about length of legs? So that might be a way that you would extract features from the features that you've already created. And eventually you'd have this long list of features, and then you might want to narrow those down. Particularly if you knew that certain physical characteristics or shapes that were recognizable from your features were unique to horses, but not to other animals. However, the model will probably tell you what features are most relevant. So feature selection can actually be done pretty programmatically as well. You can throw all the features you have, and hopefully, if you pick the right one, your model will be able to say, that's irrelevant, actually that's a great one, because you'll start to get better results. So hopefully that has explained some of the process. Obviously it's a simplification. I don't have a PhD in machine learning, but hopefully that gives you some idea of this process of feature creation. It's a term that you will see everywhere if you are doing reading about machine learning. So hopefully that's been interesting, and like I said, at some point in the future we're going to dive into what makes a good model, what we're doing, and applying to the features that we have created. So thanks very much for listening.